Question 1. What is the main disadvantage of an indirect bandgap semiconductor like silicon for emitting light? In indirect bandgap semiconductors like silicon, electrons must change their momentum to recombine, releasing energy as heat rather than light. Question 2. In 1947, who co-invented the first working point contact transistor at Bell Labs? The transistor was co-invented at Bell Labs by John Bardeen, Walter Brattain, and William Shockley, sparking the modern computer revolution. Question 3. Which probability distribution function describes how electrons occupy energy states? The Fermi-Dirac distribution function determines the probability that an available electron state is occupied at a given temperature. Question 4. What is a bound state of an electron and a hole attracted by electrostatic force called? An exciton is a neutral, bound pair of an electron and a hole attracted to each other, acting as an elementary excitation in insulators and semiconductors. 5. Which physical phenomenon is used to measure carrier concentration and identify doping type? The Hall effect is highly valuable because measuring its voltage reveals both the charge density and whether carriers are electrons or holes. Question 6. What is a semiconductor called when it is doped so heavily that it behaves like a metal? When doped to extreme levels, a semiconductor becomes degenerate, meaning its electrical properties start mirroring those of a highly conductive metal. Question 7. Which compound semiconductor material is widely chosen for high-speed electronics and laser diodes? Gallium arsenide offers exceptionally high electron velocity and a direct band gap, making it perfect for high-speed microwave devices and lasers. Question 8. What class of semiconductors relies on carbon-based molecules to conduct electric current? Organic semiconductors utilize conjugated carbon molecules or polymers to transport charge, enabling flexible displays and solar cells. Question 9. What are the two primary physical mechanisms behind charge carrier transport? The two fundamental currents in a semiconductor are drift, driven by electric fields, and diffusion, driven by concentration variations. Question 10. What process occurs when an excited electron falls back into a vacant hole, releasing energy? Recombination describes the process where a conduction band electron drops into an empty valence band hole, neutralizing both charge carriers.